notes or videos uploading problem, which I'm doing. I'm uploading the videos on notes. So let us think like this. On that day, if I'm not uploading the video or notes, there's a failure. It's a Bernoulli. I conducted the class, but I have not uploaded the notes. Yes or no kind of thing is the Bernoulli, right? So far, how I'm going to calculate the P and all? Total number of classes conducted so far, how many? Let's assume 20 for us, for our consumption. How many times I have not uploaded on time? I mean, the day on which, if I am not uploading the notes, say call that as a failure. Otherwise, it's a success. Clear? So far, how many times I have not done? Sorry? So 2 times. For our consumption, let's take 4 times. Calculation a little bit easier. So the P is P naught or P? It's a sample, it should be P, but I'm going to treat that as a P naught, which we don't know actually. Okay, so let's call P. 4 by 20 is my P. Yes or no? In future, I'm going to have, let's say, 100 days of the classes coming or 50 days of coming classes. So n equal to, in 50 days of the classes, how I'm going to upload the videos. Let us see this. You guys understood this? In coming 50 days, how I'm going to do it. So here, let's say coming 50 days, how I'm going to, this is my, what is this probability? What is this probability? Not uploading. So what are the sets then? Not uploading, right? Corresponding to this probability, that will become X, na? You guys are understanding? So what is the, at least, what is the, out of 50 classes, at least I am, 2 days I am not going to upload. 100% sure that I am not going to upload at least for 2 days. What does it mean? If I am not changed my behavior, then only this analysis out good. If I change my behavior, let's say some automatic recording, automatic upload, if I set the setting, so that once I close the session, immediately it has to upload. You guys are understanding? If such kind of technology changes, if I bring into this system, this analysis is not going to hold good. Whatever the currently I am doing, if I continue to do in coming 50 days, then only. So what I am trying to say, there is, for this analysis, the assumption is there is no process change or policy change. You guys are clear? Online? Yeah, this maybe he is right. Okay. So what is the meaning of this? At least I am not going to upload for 1 day. So this is what my analysis. You guys are understanding? Things are clear, guys? How you should interpret? How many? 5 days, at least 5 days. Yeah, that is also very, very high. 10 days, look at this. 10 days, how much is the percentage it is coming? Look at this. What is the average? NP. N is this, P is this, NP is the 10 days. Okay? So 10 days means what? 55%. Why it is coming at 55%? The average is going to stand in the mid 50%, but it may be skewed, positively skewed, negatively skewed. Look at this graph. It is little bit positively skewed. You guys are understanding? So that's why definitely my percentage is going to shift a little bit towards this. That's the reason I am getting not exactly 50%, but near to 50%. You guys are understanding? Online, please respond whatever I said. So how I plotted this graph? x equal to exactly, this is P probability of not uploading the nodes exactly for 1 day, exactly for 2 days, and corresponding probability, I plotted this. What is this graph? Is it a symmetric graph, or positively skewed or negatively skewed by looking at this data? More number of this side, more number, na? Right, positively skewed little bit. Now come back. You guys understood this? Let me do, for given same probability, I'm assuming, let's say only for 10 days of time. How this is looking like? Is it a positively skewed or negatively skewed? Huh? It is a positively skewed or negatively skewed? What is this? It is a positively skewed, right? This side, right? The tail is looking like this. The tail is which side? Positive side or negative side? If you take, this is 0, this is the positive side, this is the negative side. Which side this tail is going? Positive side, so positively skewed. You guys are understanding? So in this case, this is a positively skewed or negatively skewed? Positively skewed. Now let us keep on increasing this one. Now this time I'm making, let's say 100 or 60, 50. But compared to the previous graph, this is little bit good, symmetric, looking like a symmetric, but it's not exactly symmetric, right? If I increase this further, so let's make it 70. What about this? It became a little symmetric because this side and this side more or less same, but still it is. And let's make it 100. What happened? Looking like symmetric? You guys are understanding what I'm saying? So what is happening? If I'm increasing the sample size, how this graph is changing? Before, when the sample was less, it is a positively skewed. Now when I'm with increasing the sample size, it is becoming symmetric. Let me connect this with a real time. I mean, with the intuition. If you have only glass of sand, if you throw on the floor, you don't see a proper pattern, right? But if I increase the size of the sand, let's say 1 truckload of sand, if I put on the floor, you see this shape? So increasing the sample size, what is happening? It is becoming a symmetric. But actually it's a binomial. Binomial need not be a symmetric. Based on n, it is going to convert to the symmetric. So from positively skewed to, it became a symmetric when I'm changing the n. You guys understood this point? Now let us understand other way. Now I'm changing the p. How am I going to change the p? Let's start with the point 1. What happened? For given, I fixed my 100, now 0.1. The p value is very, very small. Now let us keep on increasing the p value. 0.2, what happened? Yeah, it became a symmetric. Let's make it 0.3. What is happening? So before it is a negatively skewed when it was a 0.1, or make it some small number. Instead of this, let's make it further small. 0. Let's say 5. Oh, it's gone this side. Something wrong? Okay. You guys need to understand these kind of things so that really it is going to give the what is the feel of the subject. What is this? Positively skewed? Positively skewed? Yes or no? Now I'm changing this to 0.052. Still it is a positively skewed. Now 0.3. What happened? Yeah, it is negatively skewed. But let us make it 0.2. What happened? Symmetric. So what is happening? First, it became a positively skewed when the p is very, very small. When for given n, I fixed n. I'm changing my p value for smallest to largest. So when I kept the very, very small, it became a positively skewed and keep on increasing. At some point, it became a symmetric. After that, if I still keep on increasing, let's make it to 0.8. Too much positively skewed, right? Maybe it's not accommodating the. Yeah, positively skewed. You guys are understanding what I'm saying, guys? So first it started with a positively skewed, became a symmetric, then it became a negatively skewed when the P is increasing. These are research-based questions. Nobody is going to ask in the interview. But people who wants to get into the higher education, definitely this kind of information is very, very useful when we are going to look into the future, future classes. You guys are understanding? This is not very important for the interview, but this is very important to get an understanding of the subject. Clear, guys? But you guys understand there is nothing difficult, right? So let me write it. What I'm saying is, for P is constant, I'm not changing the P, whether small or large, it doesn't matter. So I'm keeping the P as a constant, N is changing. Let's say here, this P is very small. If the P is very small, I'm keeping the P value, but it is a very, very small value. Now, like this, P is very small. Let's say I started with a 10 observation. What happened? Positively skewed. Now this small, I'm changing this. 20, it is changing its shape. Amen. Okay. So what is happening? It is when I change this to, let's say, some 200. Still it is a positively skewed. If I make this to 300, still, you guys are understanding? So when the P is very, very small, it is starting from where? Positively skewed. Positively skewed to it becoming symmetric. So with increasing the N, it has become more symmetric. So from positively skewed to, what is happening? So in the real world, what I do, I'm interested in the symmetry. I'm not interested in positively skewed or negatively skewed. Why? There is not too much of theories available to deal with the positively skewed and negatively skewed distributions. So what I can do, I need to collect more data. You guys are understanding? I am going to learn the theory which is related to only the symmetric most of the times. So to make symmetry, what should I do? Collect more data. I am increasing N, which means what? Sample, I should collect more sample. You guys are understanding, guys? Online? Okay. So positively skewed to symmetric. Now for P is large and constant, I am keeping the constant. N is changing. What is going to happen? You should start from the negatively skewed, right? Yes or no? If I keep P is very, very large, like 0.8, I don't know whether it is going to accommodate or not. Yeah, it's gone that side. But let me show. In a minute I'm not sure whether it can be accommodated or not. Binomial. Where is the binomial? Number of trials. So number of trials I'm keep on changing. let's say 10 trials, 20 trials, 50 trials, 70 trials, 80 trials, 100 trials, now 150 trials, but I kept the P is very, very small, right? Or maybe 0, become too much small. In separate panel of same term. Yeah. What happened? When n equal to 10 for given p equal to this, you guys understood now? What happened? Interesting, right? So this, what is the use of the tools, my dear friends? Nothing more than this. I use some tool to do the job quicker, but I need to know the concept first of all. What is the binomial random variable and all? This is P is very small, and then I am changing. P is small. You guys understood this? Now let us try same thing using the P is the large. Maybe 0.8, large enough. So we are going to understand when you say large. The 0.1 is the large, or 0.1 to 0.2 is the large. All those things we'll talk in the future. When I say, let me give an example so that you guys understand what I'm saying. Okay. Let's say you went to a vegetable market. You purchased 1 kg of tomato. You came back. Again, you waited it because you are not trusted that shopkeeper. It is coming 900 grams. What is that? It is coming 900 grams. Let's assume kg tomato costed you 5 rupees. Now I am asking you, can you go back and fight with that shopkeeper that saying you give 100 grams less? Huh? Why? Means what is the meaning of that? You are treating this 900 grams as a 1000 grams? There is no difference. This 100 grams is not the difference for you, right? You guys are understanding what I'm saying? Guys online? You guys understood what I said? Now, let's take another example. There is a gold shop. You went there. You purchased 10 grams of the gold. Okay? And you gave the, you came back. You waited it. It is coming 9 grams. Do you want to fight with him or not? So here, this 1 gram itself is too much difference for you. There, even 100 grams also not too much difference for you. So when you say that difference which is coming too much for you, you guys understood? So we are going to evaluate all these things in the future. That's what I'm saying. You guys are clear? You guys are clear? Now let me ask a simple question and think through. Let's say one has to fix every day 15 problem tickets in a production support environment. One has to fix on an average per day how many? 15 problem tickets on an average. Means what? One day you might have fixed 10 tickets, another day you might have fixed 20 tickets. The average is still it is becoming a 15. You guys understood this? Maybe do you accept, let's say until unless he fixes these 15 problem tickets, you are not going to keep in the company. You are going to sack him, fire him. Now, when I calculated the average, it is coming 14. Do you want to keep him in the company or not? How much is the difference? 1? Let me repeat what I said. 15 is the target you are given. On an average, he has to fix. He has to fix 15 problem tickets per day. Okay. Now you collected the data. You calculated the average. This is coming 14. Do you want to keep in the company or you want to fire him? Huh? Interesting question, right? Target he has to meet 15, but he did it only 14. Do you want to keep him in the company or you want to fire him? Huh? So I'm getting the different answers. Someone is saying keep him. If he is your friend, maybe you may keep it. But what science is going to tell you? You want to keep or you want to go into fire? You guys are understanding? That is the science you guys need to learn. Make sense? Just I'm not explaining how that is, we are going to do it, but you are going to learn that part. Actually, this subject is about that only. For example, you want to cross a road. Some vehicle is coming. To cross the road, it will take, let's say, 2 minutes. You calculate internally. Your mind will calculate. Yeah, it is going to take 2 minutes to reach me, or more than 2 minutes. If it is more than 2 minutes, then only you cross. Because the time it is going to reach you and the time you are going to cross the road, if there is a huge gap, then only you take a call. Am I right or not? So the difference, when I say it is a significant difference. Significant difference means my decision may go wrong. For example, the vehicle is coming, it is going to reach you in 1 minute, but it is going to take 2 minutes to cross the road. Do you cross the road? No. Always your mind is doing this statistical analysis. Now you are going to put on to the paper saying how that is, getting done. You guys are understanding? That is the science you are going to learn. Already you implement the statistics everywhere, knowingly, unknowingly. That's why I make a statement saying everyone on the earth is a statistician, including a kid. Right? Everyone is a data scientist. If that is the case. No? You guys are understanding what I said? So everywhere, this is the calculation we do. So that is the science you are going to learn as a part of the subject. You are able to connect what I'm saying? Yeah. Okay. Let us look at this. Point 8. I'm going to talk about what is the significant difference, all those things in the future. I'm not getting to know. But just I'm giving an idea where we are going to heading towards. What happened? The P, before it was a little bit of negatively skewed, right? This one, this side, not tail. Yes or no? Maybe you may not let me do a little bit of so that you understand. That's a 0.6. But this is more symmetric, right? This is little bit of change. What I'm saying is, when the sample size is increasing for a given P, it is becoming a symmetric. Is that point got into your head? So here, what is going to happen? Let me. This is a large. Now let us change the P by keeping the n is equal to n is a constant. I am keeping n is a constant. Let's change the P. Let's say make some 100 samples. I'm changing the P now. 0.1, small to big. 0.2, 0.3, 0.4, 0.5, 0.7, 0.8, and 0.9. When the P is small, it is a positively skewed. Now look at it. When I am increasing my P value, it is becoming a interesting, guys. Is it interesting? Okay, perfect. What is this? P changing. I kept n is a constant. You guys understood? So it is running from negative to, sorry, it's not negative, no? When P is small, it is a positively skewed. Positively skewed first and became a symmetric and negatively skewed. You guys are understanding now? Okay. Clear, guys? Friends, any question on this? You guys are not responding. I am not understanding. Why you guys don't respond? Huh? Okay. Next. What I have done? I covered this. I covered that. There's something I'm missing. What is the thing I'm missing? Yeah, you call properties of binomial distribution. Nothing wrong. No, something I'm missing. Just a minute. What I covered? P when I'm changing. We calculate the NP, not, and this is the expected value of x, right? This, what is the meaning of the expected value? This is a mean, right? And we calculate the V of x as NP naught and Q naught, right? So these are variance. Now understand the connection between these two. For given data, let's say I'm taking the small number. Let's say I'm taking only the, let's say 50. Let's say I'm taking this is 0.2. So what is the mean? Mean is nothing but this NP naught. You can calculate N into P. How much is this? 10. So 10 is at the center. You look at this, guys. 10 is coming at the center. Okay. What is the Q or what is the variance? 8. What is the standard deviation? Square root of variance? Root of this will become around 3. Now look at. So now this is the 3. Is the 3 or 10? Sorry. This is around 3. And use the Shibsi inequality for k equal to 3. How much this is going to be? 89% of the data should lie between what? 10 minus 3 into 3 and 10 plus 3 into 3. How much is this? 1 to 16 or 19, sorry. So what is the meaning of that? At least 89% of the data. From where I got this 89%? You guys remember? 1 minus 1 by k square, right? How much this will become? 1 by 3 square, which is equivalent to 89%. So the 3 sigma limits are going to contain at least 89% between what and what? 1 and 19? Let's go and look at 1 and 19. 1 between 1 and 19. How much is the total percentage of the data? Look at this. Around 99%. You guys are understanding? Friends online. Some. It is coming 99. So between this and where is that? These are 21. Is that 21? Sorry? Variance is 8. NPQ. I have taken the standard deviation because sigma is the standard deviations, right? I need to take the square root of it. So that's why this is become around root 18 is this much, but I have taken for our consumption, I have taken 3. Is the point is clear, guys? If I have taken from the center, this side 3 sigma, that side 3 sigma, how much I'm going to get? Around at least 89% of the data is going to fall between anywhere between 1 to 19. Makes sense or not? So that's what it is coming there also. M&D online. You guys are able to connect. So even it is a binomial random variable, still the Shepsey inequality saying at least 89% of the data is going to lie between. Now let me change this a little bit. 10. Let us take the 10. Now you look at it here. 2 plus or minus this side 3, this side 3, right? So how much is the this side? 2 minus 3 into around 1. I'm taking this is a 1. So minus 1, and this side is how much? 2 into 5. So minus 1 to 5. But actual data is going to start from 0. Let's look at. So from here to how much? That side 5. How much it is total? 99% of the data is going to lie between 0 to 5. So 0 to 5 is the majority of the data. All with me? All with me, guys? This is very, very important result. So irrespective of the type of the distribution, if you calculate the 3 sigma limits from the center, this side 3 sigma, this side 3 sigma, what it is going to give? It is going to tell you approximately what is going to happen. Here, as per the Shepsey inequality, it is saying only 89%. But for this data, if I go and calculate how much exactly it is coming, 99.36% of the data is falling between 0 to 5. You guys are understanding? These things are getting into your head online. So knowing this standard, can we calculate for 2 sigma? Yes, you can calculate for 2 sigma also. At the time my statement is going to become what? 1 minus 1 by 2 square. That is nothing but 75%. At least 75% of the data is going to fall between 75. 2 sigma limits is 75%. All are with me? You can do whatever you want. At least I said. It need not be exactly 75%. Come say come. But when I look at the data, I'll come to know the exact figures. Without calculating the things, using the Shepsey inequality, I can predict what is going to happen. Make sense? Make sense, guys? Okay. Any questions so far on the binomial distribution? Any questions? Everything is good? Okay. Now let's move to another topic. I'm closing the binomial distribution here. We are going to revisit this. Again, we are going to revisit this when is required. Like the way I use the Shepsey inequality today, I taught that long back, right? But I used it. Similarly, we are going to make use of this again, the binomial random variable. You know, I will spend another 2 to 3 hours in the future classes. Maybe 5 hours, I don't know. But just I introduced, there is something called binomial distribution. You need to understand this. Things are clear? Okay, next one. I don't remember, I always confuse myself about this Poisson distribution. POI, I believe. Please verify. I have a phobia towards the Poisson word. I don't write the things correct, but you can verify. This is, people call this a Poisson or Poisson, whatever. Okay, the Poisson distribution. Important. Important. Please remind me, once I close the Poisson distribution, I will show some case study which we have done. Just remind me, most of the times I forget. Okay, yeah. So Poisson distribution. What is this Poisson distribution? It is an approximation for binomial distribution. What is the meaning of the word approximation? Why I need to learn this? When it is binomial distribution is going to give an accurate result, but Poisson is going to give an approximate result. Then why I need to learn this approximation? Why can't I use the binomial itself? I know everything, right? There is a problem. What is that problem is, look at this. NC or this is a formula. I am writing again and again so that you guys, shall I write the P naught or P? That's fine, right? You guys understand when I am going to use the P naught, when I am going to use the P. Most of the times I am going to deal with the P only. So let me, I don't want to write. N is, sorry? Okay. N is very, very large. N is very, very large. And P is very, very small. Let us say P is very, very small. Like P equal to, I'm writing as 0.01. N equal to, let's say 1 lakh. N is very large. N is very large. Let's say N equal to 1 lakh. So let us calculate this. How I need to calculate this one? Let's say P equals to, let's say X equal to 0. What this formula will become? 1 lakh C0 P to the power of, P is how much? Power of 0 and 1 minus of 0.1 lakh. Yes or no? Yes or no? Now let's say P equal to some 5. What is this? 1 lakh C5 0. To the power of 5, 1 minus 0.0 to the power of 1 lakh minus 5. A and D. Look at this. When this is increasing, to the power of this is increasing. 0. I may have the situation where 0.01 whole to the power of some 50,000. To do that, 0.01, 0.0, 50,000, if you multiply 50,000 times, if you multiply, your computer will become unstable, right? Yes or no? It's a numerical problem. Numerical issues with your computer. Why? It is going to accept only few values, the integer, float kind of values. You guys are understanding what I'm saying? So when I'm doing such kind of look at this, 1 lakh to the power of 5C0. If this is the case, 1 lakh C 50,000, 50K, it become very, very large number, right? You guys are understanding. You guys are understanding what I'm saying? Very, very large number calculations. Very large number. So calculations become hectic. Calculations become hectic when N is large and P is small. Even my computer also cannot calculate. Make sense? My computer become unstable. Sometimes it may crash. It may crash. Agreed? You guys are convincing with the logic which I am explaining. So I don't want to use the binomial distribution. Or when I don't want to use the binomial distribution, if that is the case. What is the meaning of this P is small? Let us understand this little bit more. What is the meaning of the P is small? The occurrence of that particular event is very, very less. Out of so many trials, out of so many Bernoulli trials, that particular incident should happen very, very small. Let me give you an example so that you understand what I am trying to say. In a year, there are so many flights are happening between Hyderabad and Bangalore. So many times the flights are moving, traveling from between Hyderabad and Bangalore. You guys understand? So the N is very, very large. Every day maybe so many flights are moving. N is very, very large. So if you ask me to go and if I want to use the binomial distribution, first I need to count how many times it is happening. So I don't want to do that. When N is large, let us take. So in that N is large, how many flight crashes are happening in such flights? How many? Very, very less. P is very, very less. M and D. Let's look at another thing. How many accidents are happening at Lingampally in front of our institutes? First, actually, what I need to do? For every vehicle, I need to capture the data. In a day or in a year, if someone asks me, in a month, I want to know. So first, I need to calculate the N. N is means what here? Each traveler is a one Bernoulli. He may meet with an accident, he may not meet with an accident. Okay, sir, understanding? Okay. So first to calculate, to implement this problem using the binomial, first I need to know how many in a month N is happening, how many people are traveling. It is very, very difficult to collect the data. And the number of accidents happening in a month is very, very less. So if you see such kind of scenarios, you can take the help of a Poisson distribution instead of binomial. So here N I don't want to calculate because N is very, very large. Without calculating the N, I want to do the analysis. All are with me, but still I need no need me to calculate the P also because I don't know the N. How can I calculate the P? I'm not going to calculate the N. I'm not going to calculate the P. Without calculating these two numbers, I'm going to approximate binomial distribution using the Poisson distribution. You guys got the essence of the Poisson? Friends, online. Let's take one more example. I want to find out number of errors in a textbook. First, I need to calculate how many words are there. That is a N. Out of that, how many errors are there? But you see that P is very, very small, right? If there are too many errors, do you go and buy that book? You don't go and buy that book. So in such cases, I need to look at the Poisson instead of binomial because I don't know the N. I know the N. If you have patience, if you want to get treated without counting the number of words in the book, yes, that is a task, you can take it. But who is ready to do that? Okay, so in such cases, I need to approach what? Poisson distribution. What is this Poisson distribution? So let me write it. Hope you guys got what is the meaning of the Poisson? When N is large, P is small, I will go for, see, you guys might have studied this in the college and all, but there you might have studied differently. But here we are going to solve the industry problems. You guys, there is a chance that again you guys get into the confusion. Okay, you should be little careful. Okay, so let us take the traffic problem or number of errors in a textbook. Number of errors. If X equal to number of errors per page. I scoped my, this is very, very important. I scoped my calculation per page. So what I'm going to do? But to calculate this number of errors per page, first, what I need to do? I need to have so many pages, no? So there are, let us say, how I'm going to collect the data? Let us say, I read, let's say 10 pages or 20, 30 pages, I look for number of printing mistakes in 30 pages. But I'm not going to calculate how many number of words are there. Let me write that also. I am not going to calculate how many number of words are there. Just what I'm going to focus? While reading, it is very easy, right? While reading, I read one page, how many mistakes are there? They easy to collect the data. Instead of counting how many words are there. So X is going to be what? Number of errors. So now, what I'm going to do, out of 30, let's say I got some 6 errors. How many? I got, say, 6 printing mistakes. Mistakes. Now I'm going to calculate average number of mistakes per page. Look at this, average. So how can I do that? Divided by total. There are 6 mistakes out of 30 pages. You guys are getting? Maybe these 6 might have be there. The 6 mistakes may be there in one page. I don't know. But I read all the 30 pages. Out of 30, I count how many mistakes are there. These 6 mistakes may be coming from 1 page or 2 pages or different pages. I don't know. You guys are understanding? So this will become, how much is this? 1 by 5. This is the average number of mistakes per page. You guys are getting, or you guys are? There may be, this need not be always a fraction. There are, let's say, 60 mistakes out of 30. Possible, right? So let me write the 60, because you guys may be thinking it's always going to be a less than 30. No, I may be having more than 60, more than 30 also. So in such situations, what I'm going to have the number. What is the meaning of this? What is the meaning of these two? There are 2 errors on an average. On the average, there are 2 errors per page. Agreed? Agreed or not? I'm scoping this. If you want to make the scope maybe per book also, so at that time what I need to do? I need the entire book. I need to read entire book. In that how many errors? So at that time, how I'm going to collect the data? I need to read maybe 10 books written by or published by that particular publisher, right? You guys are getting? Maybe I might be having 2000 errors out of 10 books. So 2000 divided by 10. So that is going to give the number around 200 per book. So I scoped at the time the book as my space. In this case, I scoped my page as my space for my calculation. You guys are understanding? You guys are understanding? So whenever you have P and N is large and P is small, you are going to calculate this number. This is very easy to calculate. No need me to look at No need me to look at how many n is there, what is the p is there, because I don't know the p. Why I don't know the p? It is very, very large. I'm not calculating the n. You guys are understanding or not? Online, please respond. So far, so good. Why I'm adapting this? It is very difficult for me to calculate the n and p. I don't want to do that. But this is very easy to calculate. Right? This is very, very easy to calculate. For example, number of accidents are happening. If I want to look at the traffic signal, how many accidents are happening in front of my institute? Yeah, I'll go and ask the constable how many today accidents happened. He will give the number, right? But if I ask me out of how many vehicles, how many accidents are happened, he will say get lost. You guys are understanding at the time how many vehicle passed through. That is my n. It is very, very difficult to calculate, which I'm not going to. But I'll go and ask him, tell me today how many accidents are happened. I'll collect that data for let's say 1 month. So in 1 month, let's say 5 accidents happen. 5 accidents per month. Maybe another month, maybe 6 accidents. Maybe another month, some 7 accidents. Another month, maybe 0 accidents. I take all this data, I collect, let's say 12 or 2 years data every month, how many accidents are happening. I'll put into Excel or wherever it is. I'll take the average of all those things. The average, it is like this. You guys are able to digest what I'm saying, guys, online? You guys are able to appreciate? Let's say 24 every month data I'm collecting. Don't worry what I'm giving here. So first month, how many accidents happen? 10. Second month, how many accidents happen? Third month, only 3. This is my data. I collected this data for how many months? 20. Yeah, let's make it 2 years data. Now I'm going to calculate the average. How I'm going to calculate the average? Calculate the simple average. How much is this? On an average, what is my statement? Tell me. On an average, around 5.33 accidents happening per month. Per month. I scope my analysis in months. I can do this for week also. So this week or month or page, something like this is nothing but the space. What are these? So number of occurrences per month or week or maybe hour or maybe pages or books or book or per day or per unit area for 1 meter square area. Where I'm going to this, look at this, let me explain this 1 meter square area. What is the meaning of this? I want to understand in a glass. There is a 1 meter square glass. What is the meaning of the 1 meter square area? So this side 1 meter and this side 1 meter. So this is the glass. 1 meter and 1 meter. So the area is becoming how much? 1 meter square. This into this. So this is my glass. I want to understand how many scratches are there on the glass. So each spot is a possibility. Yes or no? There are so many points. My scratch get happen. Is it possible for you to calculate how many points are possible on the glass? It's not possible. N is very, very large. But can I go and collect how many scratches are there? Yeah, here 1 scratch, here 1 scratch. Yeah, there are 3 scratches in 1 meter square area. You guys are understanding? So I'll take maybe 20 glasses like this. I'll see how many scratches are there in each glass. It is coming, let's say, some 50 scratches. 50 divided by 20. I said 20? 20 glasses. So 50 divided by 20. How many on an average I am going to get the scratch per glass? 2.5. So like that, it is very easy to calculate because I'm not calculating if I want to use the binomial distribution, what I need to do, how many possibilities are there, the scratch getting, each point is an opportunity, no, to be scratched. You guys are understanding? Friends, online, things are clear. You need to get this into your head very, very clearly. Everyone has to respond. Please respond. I'm not interested to calculate N. I'm not interested to calculate P. You can go for the binomial. So what are the different values my X is going to take? Let's take this glass cup or take the accidents. What are the values? What is my X is going to take the values? X is what here? Number of accidents, right? What are my X values I'm going to take? It is going to take. There may be 0 accidents. There may be 1 accident. Up to? Up to what? Today I'll go and observe. Up to what? 10. Why 10? N. N is what here? Do you know the N? No, my question is, what are the values X is going to take? Think and come in the next class. What are the values X is going to take? Whenever n is small, p is large, then we might use the binomial. No need to look like that. If you don't want to use it, talk about the calculation of n and p, go for Poisson in a practical sense. 0 to infinite. X is going to take infinite because n is very, very large, right? Yes, sir. And I don't know. I'm saying infinite. One day maybe there are 1 lakh accident may happen. This is a theoretical possibility. So X is going to take 0 to infinite. So that's where I said, understanding the random variable means what? I need to first spell out what are the different values it is going to take. I've done now. So next, I need to talk about the calculation of the probability. You guys are understanding the structure of the subject? First, I need to talk about what is my random variable. I need to understand. I gave a physical meaning of it, and I need to look at what are the values it is going to take. After that, what? Probability.